Or maybe that it's all about sending out good vibes to get what you want.
Oh, absolutely. It's everywhere, isn't it? It really taps into this deep human desire, I think. This idea that our inner state, our feelings, could somehow directly shape the world around us.
Exactly. It's powerful. And often kind of sitting right at the core of this whole way of thinking, there's this proposed law of existence.
Right.
And this law, it seems to suggest two main things. First, that the universe, like, fundamentally is just made of vibrations.
Mm-hmm.
And second, that for anything to, actually exist, there has to be some evidence for it, proof it's there.
Yeah, it's a really fascinating mix, isn't it? It tries to connect the very fabric of reality, what things are made of, with how we know things, how we verify them.
It does. So, okay, our mission for this deep dive is to really unpack this whole proposed law. We're going to take it apart piece by piece.
Look at it from different angles.
Yeah, exactly. Through different lenses, the spiritual side, the scientific side, and the philosophical side, too. We're not here to say, believe this or don't believe this.
No, the goal is understanding. Where did these ideas actually come from? What are they really claiming? And critically, do the pieces even fit together logically?
Right.
And I think as we do this, we're going to stumble on some pretty surprising historical twists. We'll trace the family tree of these ideas, so to speak.
Okay.
And uncover some profound challenges to things that maybe seem simple on the surface. So you, listening, should leave this with a much more nuanced view of reality, and just as importantly, how we even claim to know anything about it.
Okay, let's start with that first big idea then. The universe is fundamentally vibration. It has a certain ring to it, doesn't it? It feels kind of intuitive. We talk about energy and vibes all the time.
It does feel right, yeah. It resonates, you could say.
Yeah.
But to really get where this popular idea comes from, we need to look back a bit. The main source, really, for the modern push of this law of vibration is a book from 1908 called The Kybalion.
The Kybalion. Okay. Attributed to 3 initiates, right? Sounds mysterious.
Very. And it claims it's revealing ancient Hermetic wisdom.
Yeah.
Secret knowledge.
So what does this Kybalion actually say about vibration? What's the core idea?
Well, it lays out something called the principle of vibration. And the quote is, "Nothing rests, everything moves, everything vibrates." Simple enough on the surface.
Okay.
But they say this principle applies to, well, everything, from the densest physical matter right up to what the book calls the all, which is their term for, like, the ultimate reality or God principle.
So it's not just physical stuff vibrating, like a guitar string.
Oh, not at all. That's the
Wow.
crucial part. It explicitly extends this idea to the mental and spiritual realms. Thoughts, emotions, moods, even your will. They're all vibrations, according to the Kybalion.
Okay. I see the link now.
Exactly. And because thoughts are vibrations, the book teaches something called mental transmutation. It's this idea that you can learn to consciously control your own mental vibrations through willpower.
Change your own vibe, basically.
Precisely. Change your own state and, they claim, even influence the mental states of others. This is really the bedrock for that whole popular idea that you can alter your reality by changing your internal frequency or vibe.
Right. The Kybalion definitely sounds like it's presenting itself as this ancient hidden wisdom. But is it really? You mentioned 1908.
Yeah, that's the thing. Despite all the claims of ancient Egyptian origins, scholarly analysis paints a very different picture. The Kybalion is almost certainly a product of the early 20th century,
Really?
deeply influenced by the ideas floating around then. For a start, the word Kybalion itself, it seems to be completely made up. A neologism. Doesn't appear in any known ancient texts or languages.
Wow. Okay, that's a pretty big crack in the ancient wisdom facade right there. I sort of always pictured it as some dusty old scroll.
It's a common image they cultivated. But if you actually compare the Kybalion to, say, genuine classical Hermetic text like the Corpus Hermeticum, the difference is night and day.
How so?
The ancient texts are deeply religious, theological. They're focused on piety, reverence for the divine, understanding God. The Kybalion, on the other hand, is much more impersonal. Its ultimate principle, the all, is described as basically unknowable and kind of indifferent to worship.
So less about God, more about...
More about the individual's power. The focus shifts completely to self-mastery, to this mental transmutation controlling your own mind, rather than religious devotion. It's almost anti-theological in tone compared to the real Hermetic stuff.
Okay, so if it's not ancient Hermeticism, where did these ideas actually originate? What was influencing the authors?
The evidence overwhelmingly points to the New Thought movement. This is a spiritual and philosophical movement that was really booming in the United States in the late 19th and early 20th centuries. The philosophical content of the Kybalion lines up almost perfectly with New Thought principles.
New Thought, I've heard that term.
And in fact, many scholars now are pretty confident that the primary author, perhaps the sole author, was a guy named William Walker Atkinson.
Atkinson.
Why him? Well, he was an incredibly prolific writer within the New Thought movement, and crucially, in 1906, that's 2 years before the Kybalion came out, Atkinson published a book called Thought Vibration, or the Law of Attraction in the Thought World.
Uh-huh.
And it contains essentially the exact same core ideas as the Kybalion, often using strikingly similar language. It looks very much like the Kybalion was Atkinson repackaging his existing New Thought ideas, but giving them this mysterious, ancient Hermetic branding to make them seem more authoritative and appealing.
So the Kybalion isn't ancient, it's based on this New Thought movement, likely written by Atkinson. Okay, tell us a bit more about New Thought itself. What were its core ideas?
Right, so New Thought, which is the real source of this popular law of vibration, kind of traces its roots back to the mid-19th century, to a man named Phineas Quimby. Yeah, he was involved in mesmerism and developed practices he called mental healing. His big idea was that illness wasn't primarily physical, but mental. It came from wrong beliefs, from errors in thinking.
So mind over matter, basically.
Exactly. He believed that if you could align your mind with what he called truth or divine science, you could overcome sickness. That core concept, the mind's direct power over the physical, was really the seed that grew into the whole New Thought philosophy.
And it developed into a full spiritual system from there.
It did, yes. It evolved into a system with a few key beliefs. First, there's usually some concept of an ultimate reality, often called infinite intelligence or universal mind, seen as omnipotent and good.
Okay.
Second, and this is crucial, it teaches that our true human selfhood is inherently divine, like we're individual expressions of that universal mind.
We're sparks of the divine.
Kind of, yeah. And third, the key mechanism connecting us to this power is the belief that thought itself is a force. Specifically, that divinely attuned thought is a positive force for good. Your mind can directly influence reality.
And that leads directly to
the law of attraction. That's the big one that came out of New Thought and is still incredibly popular today.
Ah, yes, the law of attraction. Definitely a term most people listening will recognize.
Absolutely. It's the central idea that your mental states, your thoughts, beliefs, feelings, directly manifest or attract corresponding experiences into your life.
How does the vibration part fit in there?
Within this New Thought framework, thoughts themselves are seen as these vibrations. And the governing principle is like attracts like. So the idea is the vibrational frequency of your thoughts and emotions will naturally attract people, events, circumstances that are vibrating at a similar frequency.
And this got popularized by?
Well, early on by figures like Prentice Mulford and William Walker Atkinson, as we mentioned. Then later you see it powerfully influencing people like Napoleon Hill with Think and Grow Rich, Norman Vincent Peale with The Power of Positive Thinking.
Very famous book.
Extremely. And then, in more recent decades, you've got Rhonda Byrne's The Secret, which was a massive phenomenon, and the teachings often associated with Abraham Hicks. They've really brought this law of attraction framework back into the mainstream spotlight.
Okay, given how incredibly widespread and frankly appealing this system is the idea that you can think your way to a better life, let's put it under the microscope a bit, because I'm already sensing some potential issues here. It sounds like it could lead down some tricky paths, logically and maybe even ethically.
You're absolutely right to pause there. Despite its massive popularity, the law of attraction, when you examine it closely, is riddled with some significant logical fallacies. And perhaps even more worryingly, it carries some pretty severe ethical baggage.
Let's start with the logical side. How does it hold up just as a system of reasoning?
Well, one of the main issues is that the system is kind of built to be intellectually self-sealing. It's designed in a way that makes it very difficult, if not impossible, to challenge from within.
How so? Like, it protects itself from criticism.
Exactly. Adherents often engage heavily in confirmation bias and cherry picking. They'll focus intensely on any instance where something good happened after they were thinking positively and hail it as proof the law works.
Right. I visualized a parking spot, and I got one.
That kind of thing. But they tend to ignore, explain away, or simply forget all the times they visualized something and it didn't happen. Or worse, when something bad happened despite their positive thinking. It's like only counting the hits and ignoring all the misses.
So what do they say when it doesn't work? When you visualize wealth and stay poor, or visualize health and stay sick.
Ah, that's where the unfalsifiability comes in. This is a real hallmark of pseudoscience. If the desired outcome happens, great, the law of attraction worked. But if it fails, the blame is never placed on the law itself. It's always directed back at the practitioner.
Always their fault.
Invariably. You'll hear things like, oh, you didn't really believe it enough, or you must have subconscious limiting beliefs blocking it, or maybe you were surrounded by negative energy, or you weren't specific enough, or you were too attached to the outcome. There's always an excuse that preserves the law and blames the individual.
That's convenient for the system. It
Yeah.
means it can never actually be proven wrong, can it?
Precisely. It's circular reasoning. The system defines its own success and failure conditions in a way that makes it immune to refutation. If it works, it works. If it doesn't work, it's because you did it wrong, which implies the law itself still works if only you'd applied it correctly.
So it's a closed loop. And this also sounds like it leads to another logical problem.
Yes, the false cause fallacy,
Mm.
often called post hoc ergo propter hoc, after this, therefore because of this. Just because one event, a positive outcome, happened after another event, positive thinking. The system assumes the thinking caused the outcome.
It confuses correlation with causation.
Exactly. It assumes a direct causal link without providing any actual verifiable mechanism for how a thought, just a pattern of neurons firing in your brain, could directly manipulate external reality to bring you a specific car or job or relationship. The mechanism is usually described vaguely as vibrations or the universe responding, but there's no testable explanation.
Okay, those logical holes are pretty significant. Confirmation bias, unfalsifiability, false cause. But you mentioned ethical problems, and that sounds even more serious.
It really is. This, for me, is where the critique becomes most pointed. If you take the core premise of the law of attraction to its logical conclusion that your thoughts create your reality, you inevitably run into some deeply troubling ethical implications.
So such as?
Well, the most damning one is victim blaming. If your thoughts are solely responsible for everything that happens to you, then what does that say about people suffering from terrible circumstances?
Oh, right, if you attract everything.
Then it logically follows that victims of poverty, victims of systemic oppression, victims of violent crime, people born with debilitating diseases, even victims of war or genocide, they must have somehow, through their own negative thoughts or vibrations, attracted that suffering upon themselves.
Wow, that's horrific when you put it like that.
It's a morally indefensible position.
Yeah.
It completely ignores the complex web of social, economic, political, historical, and biological factors that shape human lives and cause immense suffering, much of which is utterly beyond an individual's control or responsibility. It essentially blames the victim for their own misfortune, sometimes even for the actions of perpetrators.
That really flips the script on things like compassion and social justice, doesn't it?
It absolutely can. And related to this, the intense focus on personal manifestation, on curating your own high-vibration reality, can sometimes foster a kind of extreme self-absorption, maybe even ethical solipsism or narcissism.
How I mean?
Well, you sometimes hear advice within these circles to actively distance yourself from friends or family members who are struggling, who are perceived as having negative energy, because they might bring down your vibration and hinder your manifestations.
Avoid people who are suffering.
In some interpretations, yes. The focus becomes protecting your own positive state above all else. This can lead to a profound lack of compassion, a reluctance to engage with difficulty, and a shirking of social responsibility. It can prioritize personal feeling good over genuine human connection and support for others in need. It can seem quite heartless, frankly.
That's a really stark and, sobering perspective. It shows how an idea that seems empowering on the surface can have these really dark undercurrents when you follow its logic through. Okay, let's shift gears completely now. We've talked about the metaphysical vibration. What happens when we take that word vibration and look at it through the lens of actual science, physics specifically?
Right, and it's a world of difference. In physics, vibration is a precise mathematical concept. In classical physics, the kind we learn in school, it's pretty intuitive.
Like things moving back and forth.
Exactly. It's the periodic oscillation of an object or medium. Think of a pendulum swinging, a guitar string vibrating to make sound, sound waves traveling through air, water waves. These are movements of matter or disturbances in a field, and we can describe them precisely with properties like frequency, amplitude, wavelength.
That's the kind of vibration most of us picture. Solid, measurable.
But then things got much weirder with the advent of quantum mechanics in the early 20th century, the physics of the very, very small atoms and particles.
Yeah, quantum physics always sounds mind-bending.
It is. One of its most fundamental and strange principles is wave-particle duality. This means that tiny entities like electrons and photons, which we often think of as little balls, also behave like spread-out waves.
So they're both a particle and a wave at the same time.
In a way, yes. It's more like they have properties of both, and which property you observe depends on how you interact with them. The state of a quantum particle, before it's measured, is described by something called a wave function.
And that's a physical wave, like a water wave?
Not exactly. That's a common misconception. The wave function isn't a vibration of something physical in space. Its amplitude, its height at any point, tells you the probability of finding the particle at that specific location if you were to measure it. It's more like a wave of possibilities, a vibration of potentiality.
A probability wave. Okay. And what about the observer effect we hear about? Does me looking at it change it?
That's another area often misunderstood, especially in New Age context. The observer effect in quantum mechanics refers to the fact that the act of measuring a quantum system inevitably disturbs it, causing its wave function, that wave of possibilities, to collapse into a single definite state. But the crucial point here is that the observer does not have to be a conscious human mind. No. Any interaction with another physical system, another particle, a detector, even a photon bouncing off it, can constitute a measurement and cause this collapse. Consciousness, intention, belief, they don't enter into the standard quantum mechanical equations at all.
That's a really important clarification. Okay, so if the wave function isn't quite a physical vibration, how does modern physics describe the universe as being fundamentally vibrational? Is there a sense in which that's true?
Yes, there absolutely is, and it comes from our most successful and fundamental theory of physics right now, quantum field theory, or QFT.
Quantum field theory, okay.
QFT gives us a radically different picture of reality. Instead of thinking of the universe as tiny particles moving around in empty space, QFT says that the most fundamental components of reality are continuous, pervasive fields that fill all of space and time.
Fields, like magnetic fields.
Exactly like that, yes. There's an electromagnetic field, an electron field, a Higgs field, fields for quarks, and so on. Everything is made of fields. And what we perceive as particles like an electron or a photon are actually localized excitations, or tiny quantized vibrations in these underlying fields.
So an electron isn't a tiny ball, it's more like a ripple in an electron field.
Precisely. A stable particle-like ripple. A photon is a ripple, a vibration in the electromagnetic field. And processes like particle creation and annihilation, which Einstein's Im-C-Conric relates to energy and mass, are understood in QFT as energy being added to or removed from a field, causing it to vibrate more or less intensely, creating or destroying these particle excitations. This is the accurate scientific sense in which the universe is fundamentally vibrational. It's made of vibrating fields.
That's a really powerful image. The universe has these vast, interconnected oceans of potential, and particles are just the waves on those oceans.
It's a beautiful picture. And then taking it even further, you have string theory. Now, this is still more speculative. It's a candidate for a theory of everything, not yet experimentally confirmed.
Right, the theory with tiny vibrating strings.
Exactly. String theory proposes that if you could zoom in far, far beyond the level of quarks and electrons, you wouldn't find point-like particles, but unimaginably small one-dimensional loops or segments of energy strings.
And these strings vibrate.
Yes. And according to the theory, the different ways these fundamental strings can vibrate their different resonant frequencies, their different modes of oscillation, are what determine the properties of the particles we observe. That's like a violin string. Vibrating one way, it produces one note, say an electron. Vibrating another way, it produces a different note, a photon or a quark, or even the graviton, the particle thought to carry gravity.
So all the different particles are just different musical notes played by these fundamental strings.
That's the core idea. If string theory is correct, it would represent the ultimate realization of a vibrational universe in physics, where everything emerges from the vibrational patterns of these basic entities.
That's genuinely profound, but it sounds incredibly fundamentally different from the metaphysical vibration we talked about earlier, the one linked to good vibes, positive thinking, manifesting.
It's profoundly different. And this is where we hit a major logical problem when people try to connect the two. The attempt to use quantum physics or string theory to somehow scientifically validate the law of attraction or the ideas in the Kybalion relies on a critical logical error, the fallacy of equivocation.
Equivocation. Meaning using the same word with different meanings.
Precisely. The word vibration and related terms like frequency and energy is being used in two completely distinct and incompatible ways. One is the precise mathematical objective meaning it has in physics. The other is the vague, metaphorical, subjective meaning it has in New Thought metaphysics. The argument creates an illusion of a connection by sliding between these two different meanings.
Can you break down that difference really clearly? Physics vibration versus metaphysical vibration.
Sure. In physics, when we talk about vibration, frequency, or energy, these are quantitative value-neutral terms. They are mathematical descriptions of a physical system's state. Higher frequency means higher energy, period. It doesn't imply anything about being good or bad, positive or negative, loving or fearful. Those are human interpretations, value judgments we project onto the physics. There's no known scientific mechanism or basis for assigning moral or emotional qualities to quantum frequencies.
Okay, quantitative, value-neutral in physics, and on the metaphysical side.
In the metaphysical context, like the law of attraction, vibration is used in a purely qualitative, intentional, and metaphorical sense. It's a stand-in for an emotional state, a mood, a vibe. When someone says love has a high frequency and fear has a low frequency, they're not reporting a scientific measurement.
They're using a metaphor.
Exactly. It's an analogy, linking higher, more pleasant emotions with the idea of high frequency and lower, unpleasant emotions with low frequency. There's absolutely no established scientific evidence or plausible physical mechanism to support the core claim that a person's thoughts or feelings, their vibe, can literally alter the quantum vibrational state of their body or the universe in a way that attracts specific external events or objects based on a like attracts like principle.
So let me see if I've got this. On one hand, physics, quantitative, objective, measurable, value-neutral vibrations of fields or strings, governed by precise laws backed by empirical evidence. On the other hand, metaphysics, qualitative, subjective, metaphorical vibes tied to emotions and intentions with moral qualities, vague mechanisms like attraction, and relying on anecdote and unfalsifiable claims.
You've nailed it. They are using the same word, vibration, to talk about radically different things. The apparent connection is based entirely on this equivocation, this semantic slipperiness. It's an illusion, not a bridge built on solid ground. Science simply does not support the metaphysical claims, despite the shared terminology.
That's a crucial distinction. Okay, let's pivot now to the second big assertion of this proposed law of existence. The idea that for something to exist, there must be evidence of its existence. This feels, well, it feels very reasonable, doesn't it? Almost commonsensical. It speaks to that deep human need for justification, for proof.
It does feel very intuitive, yes. And it has respectable philosophical roots. The granddaddy of this idea, philosophically speaking, is probably the principle of sufficient reason, or PSR. It's most famously associated with the philosopher Gottfried Wilhelm Leibniz.
Leibniz. Okay, what's the core idea of the PSR?
Basically, the PSR states that everything that exists and every fact that is true must have a reason, a cause, or a ground that explains why it exists or why it is the way it is, rather than some other way. It's essentially a declaration against brute facts, things just being true for no reason at all.
So it's the ultimate why question, like why is there something rather than nothing?
Exactly. Leibniz used the PSR to argue that the ultimate reason for the universe's existence must lie outside the chain of contingent things in a necessary being, which he identified with God. This forms the basis of the famous cosmological argument for God's existence.
But is the PSR universally accepted? Do all philosophers buy it?
Oh, definitely not. It's been challenged, most famously perhaps, by philosophers like David Hume and Bertrand Russell. They argue that the universe itself might just be a brute fact. It might not require an ultimate explanation beyond itself. As Russell quipped, I should say that the universe is just there and that's all. So the PSR itself is a debated philosophical principle, not an established fact.
Okay, so that's the philosophical backdrop. How does science take this general demand for reasons or explanations and make it practical? How does it demand evidence?
Science operationalizes this demand through its rigorous requirement for empirical evidence and testability. This ties into a central problem in the philosophy of science known as the demarcation problem. How do we draw a line between genuine science and things that look like science but aren't, like pseudoscience or metaphysics?
How do you tell the difference?
One of the most influential answers came from the 20th century philosopher Karl Popper. He proposed the criterion of falsifiability.
Falsifiability, meaning you have to be able to prove it wrong. That sounds counterintuitive.
It does a bit, but it's a powerful idea. Popper argued that what makes a theory genuinely scientific isn't that you can find evidence to confirm it. You can find confirming instances for almost anything if you look selectively. Instead, a scientific theory must make bold, precise predictions that are, in principle, capable of being refuted by observation or experiment.
Like your example earlier, all swans are white.
Exactly. That's a scientific statement because it's highly falsifiable. All it takes is observing one single black swan to prove it wrong. Theories that are too vague or have too many built-in escape clauses so that no possible observation could ever contradict them are unfalsifiable.
And therefore unscientific, according to Popper. Like the law of attraction, which we discussed with its excuses for failure.
Precisely. The law of attraction, because it always blames the practitioner for failures, didn't believe enough, etc., effectively makes itself immune to falsification. It fails Popper's test, which is a strong indicator that it falls into the category of pseudoscience, not science.
Okay, so science demands evidence, and specifically evidence that could potentially prove a theory wrong. Now, what about that common phrase, absence of evidence is not evidence of absence? How does that square with this idea that existence requires evidence? Seems like a contradiction.
That's a really important logical distinction to get right, and it's often misused. Absence of evidence is not necessarily evidence of absence. It means that simply failing to find evidence for something doesn't automatically prove it doesn't exist.
So just because we haven't found Bigfoot doesn't mean he's definitely not out there.
Right. To claim that the lack of proof is proof of non-existence is a logical fallacy called the argument from ignorance. You can't prove a negative just from a lack of positive evidence. We might just not have looked hard enough or in the right way.
But surely sometimes the lack of evidence does tell us something. If I search my pockets thoroughly for my keys and don't find them, isn't that pretty good evidence they're not there?
Absolutely. And that's the crucial qualification. Absence of evidence can become strong, positive evidence of absence, but only under a specific condition, when we have very good reason to expect to find evidence if the thing in question actually existed.
Like the elephant in the room example you used earlier.
Exactly. If you conduct a thorough, competent search in a place where evidence should be readily found if the thing were present, and you find nothing, then the absence of evidence becomes significant evidence for absence. This principle underpins rational inquiry and scientific testing. It also establishes the burden of proof.
Meaning the person making the claim has to provide the evidence.
Yes, if you claim something exists, Bigfoot, psychic powers, a new particle, the onus is on you to provide positive, verifiable evidence. It's not up to everyone else to disprove every conceivable claim. Skepticism is the default rational position until credible evidence is presented.
So going back to the law of existence statement again, if something exists, there must be evidence of its existence. It sounds like this statement is subtly shifting gears. It's moving away from Leibniz's principle of sufficient reason, which was about reality itself.
An ontological claim, yes, about the nature of being.
And moving towards something more like Popper or the burden of proof, which is about how we justify our beliefs about reality.
That's a brilliant way to put it. It shifts from an ontological claim about what reality is to an epistemological claim about how we know reality, how we justify belief. Science absolutely relies on this strong evidentialist principle for justifying empirical claims. We demand evidence. But thinking of it as a fundamental law of existence inherent in the cosmos itself, that's where it runs into serious trouble. It's a very useful rule for rational thought, but maybe not a metaphysical law.
Okay, and this is where it gets really interesting, I think. If we treat existence requires evidence, not just as a rule for belief, but as this supposed universal law about reality itself, where does it start to break down? Where does this simple-sounding rule fail?
It starts to unravel pretty quickly when you apply it universally, because both existence and evidence are much more complex and varied than the maxim implies. We can identify at least 4 major areas, 4 distinct kinds of things, where the connection between their existence and the availability of public empirical evidence becomes problematic or breaks down completely.
4 challenges. Okay, let's walk through them. What's the first one?
The first is the abstract realm. Think about abstract objects like numbers, the number 7, sets, logical laws, like the law of non-contradiction, A cannot be both B and not B, or universals, like the property of redness or justice.
Things that aren't physical objects.
Exactly. They are non-physical, non-spatiotemporal, they don't exist at a specific place or time, and they are causally inert. The number 7 doesn't cause anything to happen in the physical world. So the question is, how could we possibly have physical empirical evidence for entities that are, by definition, non-physical.
Right. You can't put the concept of justice under a microscope.
You can't. Their existence, if they exist, and philosophers called Platonists think they do, is known through reason, through logical proof, through conceptual analysis, not through observation or experiment. The evidence for the Pythagorean theorem isn't found in digging up triangles. It's found in a mathematical proof derived from axioms. So for abstracta, the standard notion of empirical evidence doesn't seem to apply.
Okay, that makes sense. Abstract things need abstract proof. What's the second area where the rule gets tricky?
The second challenge comes from within physics itself, the unobservable universe. Modern physics and cosmology actually posit the existence of entities or regions that might be fundamentally unobservable, even in principle.
Like what?
Well, take black holes. We have incredibly strong indirect evidence for them. We see stars orbiting empty points in space. We detect gravitational lensing. We've detected gravitational waves from merging black holes. But the interior of a black hole, beyond the event horizon, is fundamentally unobservable from the outside. Nothing, not even light, can escape.
So we can't directly see what's inside.
Correct. Yet our theories of general relativity strongly predict their existence and structure beyond that observable boundary. We believe things exist inside the event horizon based on theoretical inference, not direct evidence from the inside.
And what about the multiverse? That's a big one in popular science.
Exactly. Many leading cosmological theories, particularly those involving cosmic inflation, naturally predict or strongly suggest the existence of a multiverse, a vast, perhaps infinite collection of other universes, possibly with different physical laws or constants.
But we can't visit them or see them?
By definition, no. They are causally disconnected from our own universe, so they are fundamentally unobservable. The evidence for the multiverse isn't direct observation, it's mathematical consistency, and the fact that it arises as a consequence of theories, like inflation, that do successfully explain observed features of our universe. Here, existence is inferred from theoretical necessity or elegance, not from direct empirical proof.
Okay, so abstract objects and unobservable parts of the cosmos challenge the simple evidence rule. What's the third challenge?
The third takes us inward, the inner world of subjective experience, or qualia. Qualia is the philosophical term for the subjective, qualitative, what it's like character of conscious experience.
Like the redness of red or the pain of a headache?
Precisely. For the person experiencing it, the existence of their own conscious state, the feeling of pain, the taste of chocolate, the experience of seeing blue is arguably the most certain thing they know. It's directly apprehended. But these experiences are inherently private and subjective.
I know I have a headache, but you can't feel my headache.
Exactly. This is related to the famous hard problem of consciousness and the explanatory gap. We can study the brain, objectively map neural correlates, see fiber firings for pain, etc. But there seems to be a fundamental gap between these third-person objective physical descriptions and the first-person subjective feeling itself.
Like Mary the color scientist.
Frank Jackson's Mary's Room thought experiment illustrates this perfectly. Mary knows every physical fact about color vision, but has only ever seen black and white. When she finally sees a red tomato, she learns something undeniably new, what it's like to see red. Her subjective experience exists, and she has direct evidence for it. But it's private evidence, not the public. Objective evidence usually demanded by science. Qualia represent a domain where existence is primarily known through first-person introspection.
That's a powerful point about the limits of public evidence. Hey, what's the fourth and final challenge?
The fourth challenge concerns the erased past. Think about specific historical events for which all evidence, every trace, every memory has been irretrievably lost or destroyed.
Like a specific conversation between two peasants 500 years ago that nobody recorded or remembered.
Exactly. Or perhaps a species that went extinct millions of years ago, leaving absolutely no fossil record. Did that conversation not happen? Did that species not exist simply because there is no longer any current evidence available to us now?
Our intuition says, no, of course it still happened. It still existed.
Right. The past event had a real objective existence in its own time, completely independent of whether any evidence persists into the present for us to discover. The loss of evidence is an epistemic problem. It affects our ability to know or justify belief about the past event. But it doesn't retroactively change the ontological fact of whether the event occurred. It highlights a clear separation between existence, what was or is, and evidence, what remains accessible to us.
So putting these four challenges together, abstract objects, unobservables in physics, subjective qualia, the erased past, it seems pretty clear that the simple statement, existence requires evidence, can't hold up as a universal law of reality.
It really can't. It's far too simplistic. What these challenges reveal is that existence itself is not a uniform concept.
Mm.
To exist as a number is fundamentally different from existing as a rock, which is different from existing as a feeling, which is different from existing as a past event.
And if existence isn't uniform, then evidence can't be either.
Precisely. The type of evidence required, or even possible, must be appropriate to the category of thing whose existence is in question. Logical proof for abstracta, empirical observation, direct or indirect, for physical objects, introspection for qualia, traces or testimony for past events. The simple evidentialist maxim tries to impose a single, often empirical standard of evidence onto a rich and diverse landscape of different ways things can be and different ways things can be known. It oversimplifies both ontology and epistemology.
Okay, let's try to wrap this up then. We set out to unpack this proposed law of existence. And what we've really found is that it's not one coherent law at all. It's more like two very different ideas stitched together, maybe a bit misleadingly.
That sums it up perfectly. On one side, you have the universe's vibration claim. We found this relies heavily on the fallacy of equivocation. The scientific concept of vibration, the quantitative value-neutral oscillations of fields or strings described by physics, is real and incredibly important.
But it's totally different from the metaphysical version.
Completely different from the metaphorical qualitative vibration used in New Thought and the law of attraction, which assigns emotional or intentional properties, positive, negative, to these supposed frequencies. That metaphysical version, originating not in ancient wisdom but in early 20th century New Thought, forms the basis of a pseudoscientific system plagued by logical fallacies and serious ethical concerns, particularly victim blaming.
And then the second part, existence requires evidence.
That principle, understood as an epistemological rule, a rule for how we should justify our beliefs, is incredibly valuable. It's a cornerstone of rational thought and scientific inquiry, especially regarding claims about the empirical world. We should demand evidence for empirical claims.
But not as a law about reality itself.
Right. As a universal ontological law, a claim about the fundamental nature of existence, it's demonstrably false. The counterexamples we discussed, abstract objects, unobservable physical realities like the multiverse interior or potentially black hole interiors, subjective conscious experiences, qualia, and the erased past all show that existence does not universally require the availability of public empirical evidence. It's an excellent guideline for evaluating claims, but a poor description of all that is or could be.
So given this deconstruction, what's the takeaway for us, for you listening? How should we approach trying to understand the world, navigating these different kinds of claims and knowledge?
I think the main takeaway is that the understandable human desire to find a single unified explanation for everything needs to be tempered with a respect for the diversity of reality and the diversity of ways we come to know it. It means adopting a more nuanced approach.
So how does that look practically?
Well, first, it means you can absolutely engage with metaphysics and spirituality. They can offer profound meaning, psychological insight, ethical frameworks, but do so with critical awareness. Understand their historical origins, like we did with the Kybalion and New Thought. Analyze their logical consistency, and importantly, scrutinize their ethical implications. Be wary of pseudoscientific claims dressed up in spiritual language.
And what about science?
Engage with science for its incredible power to provide rigorous, evidence-based, and falsifiable explanations of the physical world. But respect its domain and its methods. That means using scientific terms like vibration, energy, and frequency with their precise scientific meanings, and resisting the temptation to stretch them into vague metaphors. Doing so doesn't elevate spiritual discourse. It actually undermines both genuine science and thoughtful spirituality by creating confusion and false equivalences.
And philosophy's role in all this?
Engage with philosophy for its essential tools. Philosophy helps us clarify concepts, question our deepest assumptions, like what does it mean to exist or what counts as evidence, and rigorously explore those profound, often unanswerable questions at the very limits of human knowledge. It helps us navigate the complex territories between mind and matter, existence and knowledge, subjectivity and objectivity, without demanding overly simplistic answers.
So it sounds like the real journey isn't about finding one single, simple law of existence that covers everything, like some kind of magic key.
I don't think it is. The real intellectual adventure lies in the ongoing, multifaceted engagement with these different yet potentially complementary modes of inquiry. The scientific, the philosophical, the spiritual or existential, they all form part of the rich, complex tapestry of human understanding. So keep exploring, keep questioning, and perhaps appreciate that sometimes the deepest insights come not from finding simple answers, but from understanding the complexity hidden within seemingly simple ideas.